Hi, I'm Xiao, and this is Yuxin. We are presenting our authoring tool, Flowing Light. The goal of our authoring tool is to implement a volumetric effects generation tool which could produce physically accurate light effects. Besides, the tool also allows for art-directable effects based on some non-physical parameters.
The main capabilities of our tool includes the following two parts. Firstly, our tool can procedurally generate number of curves and manipulate them in a very efficient way. Besides, we have written a shader using randomized shader language with a user interface. With this shader, we can change the color, intensity, blurring effect of light beam, and the shader also support animation effect. In terms of technical approach, our awesome tool is mainly referring to this paper, Programmable System for Artistic Barometric Lighting, which is a 2011 Degraaff paper. We use Maya script language for all the user interface implementation. For the procedural curve generation, we implemented with Maya custom nodes, and it is implemented with Maya C++ API. Also, Maya is used for all the nodes input and output connections.
For the Magic Light shader, we completed a complete self-written shader using Renderman shading language, and used 3D Elite as shader compiler and render-to-render curves. We also used Mail to build user interface for user to adjust our shader attributes. We have implemented both physical and non-physical based shader for light beam. For physical-based shader, we give user access to start and end color of curve beam, and also overall light intensity and blurring effects in both width direction and length direction. For non-physical shader, besides the attributes in physical-based shader, we give user more freedom to adjust light effect. User can use a ramp color part to control light beam color from start to end, and also a gradient control part to control intensity of light beam in a similar way. User can also enable animation effects.
Here is a Maya workflow demo. Users start by generating three base curves. They represent the start shape, end shape, and main shape of the volume. And secondary curves are generated by interpolating from the start shape to end shape. Users can change the volume of the light by adjusting the control points of these three base curves. Users can also change the number of secondary curves. Besides, our tool also provides users with more localized control of these secondary curves. Users can change each control point of the secondary curves.
After generating the curves, we shall first assign a geometry attribute with Maya curve geometry to the curves and assign a shader to the curves. First, we are representing the physical-based shader. We can change the start and end color of the shader. And we can also change the overall intensity of the shader and the blurring effects of the curves. We can also assign a non-physical based shader to the curves. And we use Mail to write a user interface of this non-physical shader because the attributes is complicated. We use a ramp attribute to represent the color from the start to the end of the curves. So the first color of the color ramp part is the start color of the curve beam. And we also use a gradient control part to control the intensity of the curve beam. And we also enable animation effects of the curve in non-physical based shader. Fourth is the attribute that represents the section of the curve which can be seen in each frame. And after we set up start and end frame, the prop goes through the whole curve and ends the animation. We also test our shader on the fonts to see the effects.